Okay, this one is for phenol. So next one is a phenol reaction. So this is an example of phenol. We have isophenols, orthochlorophenol, cresol, parahydroxybenzoic acid, and also what we call with catechol, resorcinol, hydroquinone, and salicylic acid. Okay, phenol can be synthesized from many processes, but I will only give you just one process from cumin. What is cumin? Cumin is an isopropyl benzene. This is the structure of cumin. This is alkyl benzene, and this is a isopropyl group attached in benzene ring. So this is called as cumin. So cumin oxidized with air produce the cumin hydroperoxide, and the following reaction with aqueous acid will form phenol and acetone. So cumin production from isopropyl benzene is conducted by oxidation by air or oxygen, followed by the reaction with aqueous acid, and then will form phenol and acetone. Remember, the oxidation of isopropyl benzene of cumin by air, oxygen, will produce cumin hydroperoxide. Okay. What is the product of the oxidation cumin by calcium permanganate? The product of oxidation of cumin by calcium permanganate will produce the benzoic acid. Remember the previous slide, okay? But the oxidation of cumin by air or oxygen, the product is cumin hydroperoxide. Followed reaction with the acid will generate the phenol and acetone, okay? And also phenol can be synthesized from the specific plant to get the essential oil. For example, eugenol, this is the eugenol, isoeugenol, and phenylene. Okay, phenol can also have the ring substitution reaction. The concept is similar, but because the phenol has the strong activating group, then some of the reaction will be a little bit different compared to general ring substitution. Phenol can have the salt formation, ether formation, and ether formation, but I only focus on the ring substitution. Remember, only the ring substitution. Okay. Okay. As the general substitution reaction, phenol also can have the reaction nitration, but in phenol, the type of nitric acid is the concentrated nitric acid, asam nitrat pekat, or aqueous nitric acid, asam nitrat encer, will produce different product. So the reaction of phenol with concentrated nitric acid will produce 2,4,6,3-nitrophenol, which is mean that all the possible position of phenol will be filled with nitro. So all possible position in phenol. Remember, phenol is a very strong activating group. So phenol is activating group. So the reaction substitution will produce a product in auto, meta, and para position. So all the will produce product in ortho and para position. So all position of ortho and para will be filled with nitro group. Okay, remember phenol having hydroxyl group will produce the product in ortho and para position. But in nitration with nitric acid, all the possible ortho, this is the ortho position, this also ortho position, will be filled with nitro group even in para position. So is it possible to get the mononitration with phenol? Of course, the mononitration can be formed by nitration with aqueous nitric acid. If the aqueous nitric acid is used, then the nitration of phenol will follow the general substitution reaction. So will generate product in ortho and para. Ortho and para position. Okay. The next we go to the sulfonation. In sulfonation of phenol, the temperature has a different effect on the direction of substitution. If we want to produce a product substitution in ortho, then we have to use a low temperature. Okay. On the other hand, if you want to produce the sulfonation in para position, then choose the high temperature of sulfonation. Okay, I think it's clear enough here. Next is phenol halogenation. So reaction of phenol with bromine water will produce the bromination in all possible position of phenol. This is a cresol, orthocresol, a phenol with a methyl group attached in ortho position. So there are two possible position that can be filled, which is in ortho. Remember, don't forget with the third substitution. Okay, cresol for third substitution, then the product will be in ortho or para substitution. Okay, but in reaction with bromine water, all the possible position will be filled with the bromo group. Okay. Okay, even if a group already attached in phenol with the bromination but using the bromine water, then the sulfonate group can be replaced by phenol in condition of more mole of bromine and all bromo group, okay, all bromo group will attach in all possible position of phenol. Okay. So if we want to get monohalogenation, don't use the usual halogenation. Remember, for usual halogenation, we can use the catalyst of aluminum chloride or ferric chloride. So in case of phenol, choose solvent, low polarity solvent such as carbon tetrachloride or disulfide carbon to get the monohalogenation. Halogenation means that only one halogen attached in benzene ring.